Hello everyone. Today we're looking at smallest substring with identical characters. This is from Weekly Contest 429, and this solution will cover both question 3 and 4. So the solution you can use for both part 1 and part 2. So the question reads that we're given a binary string s of length n, and we're also given an integer num ops. So we're allowed to perform the following operation on s at most num op times. So we can select any index, and we could flip the element at that index. So if that element is 1, we could change it to 0, and vice versa. So what we want to do is we want to minimize the length of the longest substring of s such that all the characters in the substring are identical. And we want to return the minimum length of that substring after operations. So we have the example 0, 0, 0, 0, 0, 1, and we have 1 for our num ops, and we're going to output 2. And why do we output 2? Well, what we could do is change this element at position 2 to a 1. Then what we have here is the longest continuous substring of the same characters is 2 here and 2 here. So because we can use that one operation to change this 1 and get a continuous substring of at most length 2, this means that we want to return 2 because this is the shortest substring that we could possibly get with this one operation. So we're going to take a closer look at that example, but before we do, I want to kind of go over something that's going to be pretty critical for this problem. So let's say we have these two continuous substrings here. So this one's of length 9, this one's of length 7. So let's say, what if we wanted to change this substring into a substring that has at most 3 continuous characters at once? So how would we do that with flips? So we could say, let's start here. So we have 1, 2, 3. So at this point, we know that we want to have at most 3 continuous characters. So here, we'd want to flip this over to a 1. So now we have 3 here. So let's continue again. So we have 1, 2, 3. And again, here, we want to have at most 3 continuous characters. So we flip this to a 1. Okay, let's do the similar thing here, but let's say here we want to have up to 4 continuous characters. So we can do 1, 2, 3, 4. We flip this, and then we come here, and we don't have to do anything here because this is already less than 4. So why did I demonstrate this? Well, this is kind of going to be something that is pretty critical to understanding this problem. So what we want to do in this problem is we kind of want to break our string into different segments of continuous characters. And you can imagine for this question, we have 2 segments. So we have one segment here of length 5 and this segment of length 1. And how are these segments going to help us? Well, we could use this logic here on each segment. And as we go forward, you'll kind of see how that works. But I kind of just want to develop a formula here that we can use in order to effectively work with these segments. So you'll see here that with a segment of length 9, we could use 2 flips to make sure that we have substrings of at most length 3. So if we do this formula, 9 over 3, our desired length, plus 1, that actually gives us 2, which is the number of flips required to make a substring of this length. Similarly here, we could do 7 divided by the desired length, 4 plus 1 equals 1, which is the number of flips we had to use in order to get a substring with a max length of this. So we can boil this observation down to this formula. So if we take the total length of the segment that we're working with, and we divide that by the desired maximum length of the substring plus 1, this gives us the number of flips we need to make in order to say, if I flip these, then the maximum length of a substring will be guaranteed to be this amount. So I want to keep this equation in mind as we actually solve this problem. How do we actually use this observation to solve this problem? So the first thing we want to do is let's think about breaking this down into segments, because we said we wanted to work with segments of this substring. So we're going to have an array which basically tells us how long all these continuous segments are. So you see, for this example, we have one segment of length 5 and one of length 1. So now, what are we actually going to do here? Well, for now, let's just pick a number. Let's say let's say we could assume that we want to make the longest continuous substring to be of length 4. And let's just try it out and see what happens. So we could apply this formula here. So we could do 5 divided by 4 plus 1. This will equal 5 divided by 5, which will equal 1, right? So we could do this with one flip here. And then what we could do here is we have a segment of 1 divided by 4 plus 1. And this is just going to equal 0, basically. So we'll see here that we could do this, right, with one flip. So to make sure that our longest length in this segment is 4, we could do one flip. And then for this segment here, right, we don't have to do any flips. So I'll just reiterate kind of what we're doing here. We're going to take each segment, and for each one, we're going to see how many flips does it take to make sure that the longest substring in there that's continuous is this desired number. So we're doing that for every segment here. So we'll see in this case, it only takes one flip for this entire thing, right, to get that. So could that be our answer? Well, yes, it could be. But remember, we want to minimize the amount that our substring can be, right? We want to find the shortest length. So we found 4, but now maybe do we want to check 3 next? Do we want to check 2 next? We want to check 1 next, right? Because we don't know if 4 is going to be the smallest. We just picked this number out of thin air, right? So we could then go down and like search all these values and try to find which is the smallest one. But really, this is a great use case for binary search, right? What we're going to do is we're going to basically pick a length, and then we're going to apply binary search. What we're going to do is we're going to check 2 conditions. Here, we could say, okay, well, we actually can do this with the flips that we have, right? We are given one flip. It only takes one flip to get to that desired length. But we want to find a smaller one. So in this case, we would actually go to the left, right? So we really have 2 cases here. We could pick a number, and then we could try that out and see if we can make substrings of that desired length with the number of flips that we have. If we do, we want to check if we can do a smaller one, right? Because we don't know if this is the minimum. So we could say, all right, well, I know that I can use this number, but let's try to go to the left and find a smaller one. If, on the other hand, say here we needed 2 flips to do this, well, we could say, all right, well, I only have one flip, right? So this is not actually a valid option. So I clearly need to make the substrings that I'm looking for bigger. So here we would actually move our values to the right. And basically what we're going to do is just apply binary search on the length of the substring that we are trying to make. And basically what we are going to do is just kind of keep doing this binary search until we find the minimum value. And we're going to do that based on this condition right here. This will make more sense to when we get into the code, and you'll kind of see exactly how we're applying this operation as well as this equation that we had developed. So for this problem, there's also one other edge case that we want to consider. So the algorithm that we developed above, it works very well for substrings that are of size 2 or greater. But there is a kind of edge case where we might want our substrings to be of length 1. And let's really think about what that actually looks like. So for substrings of length 1, we really have 2 possibilities. So we can start with 0. But remember, we want our longest continuous substring to be 1. So then the next one would have to be 1. Again, this can be at most length 1, so it would have to be 0, then 1, then 0, then 1. Or vice versa, what we could do is 1, 0, 1, 0, 1, 0, right? So potentially, we could also have alternating substrings where each substring is of length 1. And this is kind of a special case. So how do we actually handle this? Well, what we could do is we could actually take our original string here and we can compare it to these 2 strings. So let's do this comparison first. And let's see how many mismatches we have. So we have a mismatch here, a mismatch here, right? So we have 2 mismatches. Let's compare here. So we have mismatch here, mismatch here, mismatch here, mismatch here. So here we have 4 mismatches. So what am I actually doing here? Well, say for example, our num ops for this problem is 1, right? In this case, both of these are greater than this value, right? It's going to require 2 flips of this substring to make it to this, and then it's going to require 4 flips of this substring to make it into this, right? So why are we actually doing this? Well, if we ever check these cases and one of these is less than or equal to this number here, say this was 2, well, this means that we could use our flips to convert it into one of these strings, and in this case, we would just return 1. And why would we return 1? Because we could use our flips to convert this into just an alternating substring, right? So in this special case, if the number of our flips that we need is less than or equal to the number of ops, we can convert it into one of these strings, and we can guarantee that the size of the substrings that we will have will be at greatest 1. This is another edge case we have to consider along with our binary search case. So what's the time complexity of this algorithm? So first we're going to have an O of n, right? And this is to go through our substring and count up all the segments and to make this segments array, right? So we'll have something like this, our segments array. Then what we want to do is we're going to again do 2n, and this is going to be our comparison for 1, right? So we're the case where we want to have a substring of 1. We're going to go through that substring 2 times and just do comparisons to that original string. Then for our main binary search, it's going to be n log n, right? Because our binary search is going to be a log n operation, but we're potentially going to be going through n values, right? So n can be the length of our entire string, right? And we basically want to check values from 2 all the way up to the possible length of our substring, because it's possible that the smallest substring that we could make is the length of that entire string. So overall, this is going to be an n plus log n log n operation. We can simplify this down to just n log n. Let's hop over to the code and see exactly how this works. So the first thing I want to do here is set up my segments array. So I'm just going to start with an empty array. I'm going to start with a consecutive value of 1 and just keep track of the last element that I've seen. Now I'm going to iterate through all the elements in the string from 1 to the end, and if whatever I'm looking at does not equal our last value, I'm just going to say that I've finished a segment here and add it into my segments array. Then I'm going to update my last value and make my consecutive 1. Otherwise, this is the case where whatever I'm looking at is the same as my previous value. So here I want to update my consecutive just by 1. Then once we're finished, we're going to have some value left over in our consecutive, so we just want to add that into our segments array. So after we do all this, essentially what we have will be an array where each element is the length of a continuous segment of that string. And then here's where we're going to handle our edge cases, right? So one edge case is where we don't have any operations. In this case, we can't actually do anything. So in this case, what we do is we just say, I'm just going to return the largest number that is in my current segments array, right? Because remember, this is the smallest possible substring that we can make, right? Whatever is the max in there. So this is going to be our answer in this num ops equals 0 case. Then otherwise, we're going to handle the case where we want to check if we can make an alternating substring, which is this code block right here. What we're going to do is we're going to do 2 for loops. This is the case where we're going to assume that our string starts at a 0, right? So what we're going to do is we're going to go through every element, and we're going to say, if this does not equal whatever I'm currently looking at, then I'm going to increment this value by 1. And this represents needing a flip in order to convert that string into what I am looking for. Then I'm just going to update. So if I have 1, it becomes 0. And if I have 0, it becomes 1. Then I do the same thing, but I'm going to start at 1 this time. So then I'm going to assume that my string that I'm looking for starts at 1 and do the same logic. So then after that, what I'm going to say is that if one of these is less than or equal to the number of operations, it means that I actually can flip that my current string into an alternating substring of 0101 or 1010. And in this case, I just return 1 because this is the smallest possible substring that I can get. If we don't hit this case, we have to do our binary search. So we're going to search all the values from our left all the way to the length of our string. So while my left is less than or equal to the right, what I want to do is I'm going to get my midpoint, and then I'm going to initialize this flips needed value, which just tells me the number of flips that I need in order to convert this string into a string that has at most a substring of mid length. So I'm going to go through each segment and I'm going to apply that equation we developed. So I'm going to take the length of my segment and I'm going to divide this by my mid value plus 1. And again, this is the total length of the segment we're looking at. This is a desired value of the substring we're trying to create, and then we just add 1 to that for our equation. So if the number of flips that I need are greater than the number of operations that I have, it means that I cannot do this, and I have to make the substrings that I'm trying to create bigger. So I'm going to increase my left value to mid plus 1. Otherwise, I have found a valid substring size, but I want to see if I can make a smaller one, right? Because I want to find the minimum. So in this case, what I'm going to do is move my right to mid minus 1. Then finally at the end, I'm going to return my left value, which should be my answer. So let's submit this and make sure that it works. And it does work. So this is a pretty tricky problem, requires a lot of kind of DSA knowledge and some pretty tricky insights as well. So if you didn't get it, don't feel bad, just keep practicing. If you liked the video, please like and subscribe. It really helps the channel, and thank you for watching.